Welcome back. Let's take a look at this figure right here, this RUTS figure. And we want to label a few pieces of information. We want to show that angle U is congruent to angle S. So we're looking at this angle here and this angle right here. Now, in geometry, we have some special notation for situations like this. When we know that two angles are congruent, or they have the same angular degree, we're going to put a little arc right here. And this arc represents that this angle is congruent to this angle. Now we want to show that angle R is congruent to angle T. All right, now our notation is going to be similar. It's just going to be slightly different because we can't necessarily use the exact same notation to show that angle R is congruent to angle T. We can't just put one ring right here, because when we do this, it's a little ambiguous. You know, even though we have different colors here, all four have one ring, so we might assume that all four angles are the same. In this case, it's clearly not, because these two are acute angles and these two are obtuse angles. But with some angles, it's a little trickier. It might, you know, they might all look the same, but they're not all the same. So what we're going to do, when we have two or more pairs of congruent angles, we're going to put some more rings around it. So for these two, angle R and angle T, we're going to put two rings just to show that these two angles are congruent, but they're not congruent to these two angles. Okay, so pretty straightforward. Let's take a look at the next one. We want to show that the segment, we want to show that the line segment RU, we want to show is congruent to the line segment ST. So we want to show that we want some notation that says this side is equal to this side, or this side is congruent to this side. And we, just like with angles, we actually have a special notation for that, and it's just these little dashes right here. We put a little dash here and a little dash here. That means that this side is congruent to this side. So these two line segments are congruent. And we can also show that UT, if we want to show that UT is congruent to RS, that these two opposite sides are congruent, we can actually use some notation just like we did in the angles. We're going to use just two dashes instead of one. So that means that these two sides are congruent and these two sides are congruent, but the two congruent pairs aren't congruent to each other, if that makes sense. So it's just a little notation. We need to get very familiar with this because we'll see it all through this course. Okay, so this is just the very foundation of what we'll be studying. Okay, let's look at the next one. Let's take a look at this angle. It's a regular old acute angle, angle ABC, and we want to sketch and label an angle bisector of a ray BD. Okay, so let's go ahead and we know what an angle bisector is. An angle bisector is just a segment, or a ray in this case, that divides this ABC angle in half. So we want a ray coming out from the point B, starting at the vertex B, and we want it coming out that splits this angle in half. And it doesn't have to be perfect. We just want to have it be an accurate representation. All right, so this is a ray BD. Here's our point D. So ray BD is an angle bisector to angle ABC. All right, now using this information, we want to figure out the following. Let's say we're given the measure of angle ABC. So the measure of angle ABC, let's just say it equals 50 degrees. We want to know what this angle is. We want to know the measure of ABD. And by definition of an angle bisector, we know that this ray right here cuts the ABC angle in half. So this half is going to be equal to this half. And if you recall from the angle bisector, or excuse me, the angle addition postulate, we know that this angle plus this angle is going to equal the larger angle. So the larger angle is 50, so we know that ABD plus DBC is going to equal 50. And since this is an angle bisector, ABD and DBC will be equal, so they both have to be 25 degrees. And that makes sense, because if this is 25 degrees and this is 25 degrees, then add them together and it gives us 50 degrees. Okay, so it's very interesting. We can use the angle bisector and addition, or excuse me, with combined with the angle addition postulate to find out some various pieces of information that can be very helpful in solving problems, especially real-world applications. Let's take a look at the next one. Let's say we have, let's label this, let's say we have R, S, T, U, V, W, X, and Y. Let's say we have a rectangle right here. And we'll actually prove later on that the rectangle, the sides of the rectangles, the opposite sides are congruent. So this side is going to be equal to this side, and this side is going to be congruent to this side. And we'll actually prove this in a later video that this is indeed true for all rectangles. But for now, we want to assume that the opposite sides are congruent and that this midpoint V is, this point V is the midpoint of RY, of this segment right here, and is also the midpoint of this piece right here, this UW. Okay, that's very important because knowing that V is the midpoint of these two lines or these two segments, we can find out, or it can help us find out, all this information that we want to know. Okay, so we want to find out these pieces of information. So let's go ahead and get started. Let's say, so we want to find UV first. So we want to find this segment right here. We want to find this distance. And we can do that because V is the midpoint of UW. And we know UW because UW is congruent to XY. So UW is 48 centimeters. And since V is the midpoint of UW, it's going to be half of 48 centimeters. So it's going to be 24 centimeters. All right, just using a little intuition, not a whole lot going on here. Let's take a look at the next one. We have RS. We want to know this distance right here. This is actually going to be fairly simple because it's going to equal the same distance as UV. Since this V is the midpoint of this line right here, we know, and more importantly, it's the midpoint of UW, we know that this line is going to be equal to this line. So UV is going to be equal to RS, and we already found UV, so RS is 24 centimeters. All right, so far so good. Let's take a look at RT. RT is this length right here. And this, since this is a rectangle, we're going to assume that all the opposite sides are congruent. So XY is 48 centimeters. The opposite side is RT, so RT will also be 48 centimeters. All right, nothing to write home about here. Let's see, we have VY. We want to find this distance right here. Well, since V is the midpoint of RY, that's going to cut RY exactly in half. And by the segment addition postulate that we used a few sections ago, we know that 26 centimeters is going to be this distance right here. This segment's going to equal this segment, so VY is going to equal 26 centimeters. And that's by the segment addition postulate. Next we have RY. RY is this total distance. And since we know that we can find this, derive this a few ways, V is the midpoint, so we know that we can find, we need to find VY and we can add them together, but we already found VY. This is 26 centimeters right here. This is 26 centimeters, so if we add those together, that will give us 52 centimeters, which is the total distance of RY. All right, fairly simple. Let's take a look at TY. TY is going to be the same distance as RX. We don't know RX, but we know this length right here is 10 centimeters. And V is the midpoint of RY, this segment right here. So we know that this TY is going to be just double this segment right here. So TY is going to be 20 centimeters. Just using this midpoint as a very important focal point to find these various distances. All right, and let's take a look at the last one. We have UX. Now, UX is just going to be equal to this section right here. Since V is the midpoint, we know that 10 centimeters cuts it. This line right here is going to be equal to this side, this side, this side, and this side. So UX is going to be just 10 centimeters. Okay, so most of this is very intuitive, and if you think about it, it's actually very straightforward given the information. So we'll actually later on prove that all rectangles have congruent opposite sides, and it's actually a fairly cool proof that we'll see in a later video. So take a look at this a few times. This is a very fundamental foundation of what we'll be studying in geometry. So I'll see you soon.